All right, so yesterday you did a lot of degrees, um, and you evaluated sine and cosine at those degrees, and you got a graph. So now I want to talk about the graph in terms of radians. So we're going to talk about sine. So the sine at, we'll start at 0. The sine at 0 is 0. And this could be looking at your unit circle, or you can use your hand trick on some of these. The sine at pi over 2 is 1. We're going to call this 1. The sine at pi is 0. The sine at 3 pi over 2 is negative 1. Oops. So I'm calling this 1 and negative 1. And the sine at 2 pi is 0. So essentially, this should have been the graph, pardon my terrible graphing, that you got for your sine function. Now, I did have you go to the left and a little bit further this way as well, because we went past 360, and we also did some negatives. So here, the sine of negative pi over 2 is negative 1. The sine of negative pi is still 0. Oops. There we go. Negative 3 pi over 2 is 1. And negative 2 pi is 0. So you'll notice it still keeps that same, oh goodness, this is really terrible, sorry guys. It still keeps that same wave-like motion. But really, I want you to hone in on that 0 to 2 pi, because that is considered a period. All right, so a period of this function is from 0 to 2 pi. We're going to talk about amplitude. So here, this is our line that divides our graph. From here, you go up as high as 1. So our amplitude would be 1. Your amplitude is 1 for your basic sine parent graph. So again, when you hear sine, I want you to have that basic graph in mind. Okay, that basic graph, there's your one period of that function. All right, let's do cosine. Cosine probably looked very similar. It looks very wavy, but there's subtle differences, like the actual numbers. When you take the sine of 0, the cosine of 0, you get 1. When you take the cosine of pi over 2, it's 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0, and 2 pi is 1. So again, that basic graph, I'm hoping you saw this yesterday. Again, yesterday we kept it going, right? We went past 360, and we went negative as well, but you'll still see that same motion, right? We're going to go back down to 0, to negative 1, to 0, to positive 1, and you're going to see that wave-like. All right, good enough. Again, your amplitude is still 1, and it still looks like a wave, but I want you to have, again, that 0 to 2 pi. 0 to 2 pi, we actually look quite different than the sine graph. So cosine graph hits, dips down, comes back, comes up. Okay, so the cosine graph versus the sine graph, they do look different on that, over that period of 0 to 2 pi. But in the scheme of things, they might look very similar when you start just getting those waves, right? Going more than one, just one period. Okay. So this is in terms of radians. So I just wanted you to see how they kind of coincide. And obviously, we graphed a lot less points than yesterday. So amplitude is the height of the function from the center line. So going back to your graph, like I said, that x-axis was our center line. Our amplitude is 1. changes in this value are considered vertical stretches or compressions. So you can vertically stretch out your graph and increase your height, or you can compress it and make it smaller, short and fat. Period for sine and cosine is 2 pi. So changes to this period would horizontally stretch or compress your graph. All right. So amplitude. Amplitude is always going to be if there's a number before your sine or cosine. And it's always the absolute value of that number. So whatever the number is, you want to take the absolute value. All right. So this one, notice there's a 2. Absolute value is 2. So notice my graph goes as high as 2. Notice my period did not change. It still goes from 0 to 2 pi. Okay, from 0 to 2 pi. There's my cosine function, right? Starts high, goes low, comes back up. All right. So here, they give us a function, y equals 3 sine of theta. So my amplitude is now 3, and you're going to graph it. So I'm just going to graph the 0 to 2 pi both ways. Now my period still hasn't changed, so it's still going to be from 0 to 2 pi, and we're still going to have oh, I did that wrong. 0 to 2. Hang on. There we go. From 0 to 2 pi, halfway is pi, halfway here is pi over 2, and 3 pi over 2. So we still have the same values. The only thing different is our amplitude, instead of being 1, is going to be 3. So we're sine, so we're 0, 0. Pi over 2 is normally 1, now it's going to be 3. Pi is still 0. 3 pi over 2 is normally negative 1, now it's going to be negative 3. And 0. So if you have the basic concept of the graph, saves you a lot of time. You don't have to necessarily evaluate it at all those values. We could go the other way as well, all the way to negative 2 pi. Right? So we have negative pi is halfway, negative pi over 2, that's 2, and negative 3 pi over 2. And again, you can keep that going. Negative 3, 0, 3, 0. And you can keep, you can keep that wave. Okay. Just know that my amplitude changed to 3 this time. Now your period can also change, and this is basically how you figure out your period. So it's normally 2 pi. K is whatever you're taking the sign of that value with in front of theta. So 2 pi over k is what's going to get you your period. So here, notice my k is technically 1/3, right? So you would say 2 pi over 1/3, and we would multiply by the reciprocal, so we get 6 pi. So my new period is 6 pi. All right, and if you see here, this is from negative 3 pi to positive 3 pi is a period of 6 pi. But we would probably go from 0 to 6 pi. Okay, 0 to 6 pi would show us. But this is one period of that function. All right. So let's go ahead and state the period and then graph. So here, technically, this is cosine of 1/2 theta. Right, theta over 2 is 1/2 theta. So our period is 2 pi over k over 1/2. And we're going to multiply by the reciprocal, keep, change, flip. So our new period is 4 pi. You might say, what does that mean? Right, my amplitude, this is still a 1, so my amplitude is still 1. So what does it mean if my period is 4 pi? That means we're going to go from 0 to 4 pi. Okay. We're still positive and negative 1 because my amplitude is still 1. And now you have to find those other marks, right? So halfway, 4 pi would be 2 pi. And then halfway, 0 to 2 pi would be pi. And then I kind of just see how they're between 2 pi and 4 pi would be 3 pi. So you want to get those 4 markers. And then you graph your cosine function. Remember, it starts up high, 0, oops, 0, negative 1, 0, 1. And you can get that full cosine wave. And you could continue the pattern this way as well and go to negative 4 pi. Next one, this actually has 2 things going on here. So here your amplitude is now 1/2. And your period is going to be 2 pi over 4, because k is 4. So your period is now pi over 2. So it's going to happen a lot quicker now. So we're here. We're going to go 1, negative 1. And again, pi over 2 is my period. Half of that would be pi over 4. Half of that would be pi over 8. So notice the pattern. Pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. So you kind of have to see how to divvy it up. And then you're doing sine. So you're going to do 0. Remember, we're only going up to 1/2. Up. Even. Oops. Even. Down. Even. So you're going to notice it a lot tighter to your x-axis. And over a 2 pi interval, you're going to have a lot faster. Okay, a lot faster sine wave. And these are just 2 more examples. Notice the negative. I'll probably just do one of these because I'm going to run out of time. The negative is going to flip. So instead of like if you're doing sine, remember your sine goes up, down, up. It would go down, up, down. Okay, so it's just going to flip it. If it was cosine, positive goes this way, negative. Oops. We'll go that way. All right. So let's do this one real quick. We have 1/3. So we're going to do, I'm just going to do a really big 1. So that'll be my 1 and my negative 1. My period is 2 pi over 3. So it's 2 pi over 3. Half of that would be 2 pi over 6, which would be 1 pi over 3. So I might erase that. Hang on. If I can get my tools working. We're going to put this as pi over 3. So 2 pi is over 3. Half of that would be 1 pi over 3. Half of that would be 1 pi over 6. So notice 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. And then we can do our sine function. Remember, you only go up to 1/3, and remember, we want to start down first. So we're still at 0, but instead of going up to 1/3, we're going to go down to negative. So we're going to start off down, up, oops, up, 1/3, 1/3. So we're going to go down, up, down. All right, so it just flips that function. Same concept here. It's just going to flip that cosine function. All right. Get the homework done. Bye, guys.